let's look at question number 1 here. So when gasoline burns in an automobile engine, the heat release causes the carbon dioxide and the water vapor produced to expand, okay, which pushes the pistons outward. Okay, so any excess heat is removed by the car's cooling system. The question here asks to determine the change in energy if the expanding gases do 451 joules of work on the pistons and the system loses 325 joules to the surroundings as heat. Okay, so one thing we look at this question, what we want to write down first is that we know delta E. Okay, we have an equation that we can use. Delta E, say, of the system. Okay, that's going to be equal to the heat that is added to the system plus work that's done on the system. Okay, so obviously the system will go up in energy if we add heat to it or if we do work on the system. Okay, and if we look at this case here, what's our system? Well, our system in this case, and pretty much always in chemistry, our system is going to be the reactants and the products. Our system is equal to the reactants, okay, the reactants and the products. Reactants plus the products. Okay. Okay, so this reaction produces heat. Okay, so energy is lost by the system. Okay, so energy is not being added to the system. So in this case, the 325 joules that's lost to the surroundings as heat, that's going to be minus 325 joules. Okay, plus, now in this case, the expanding gases do 451 joules of work on the pistons. Okay, so the pistons are expanding. Work isn't being done on the system, so this also will be negative. So this is negative 451 joules. Okay, so delta E of the system. Okay, delta E of the system. Okay, in this case, is going to be equal to minus 776 joules. So some of that energy went into doing some work, okay, and of course some was lost as heat. Okay, the more we can use this heat and convert it to work, the better, the more efficient the engine will be. Okay, so let's move on to the second question.